Okay, so hi everyone. In this video, we're going to have a short lecture on measures of non-central tendencies, and this is similar in solving the median of which is one of the measures of central tendencies. And remember that the median divides the distribution into two equal parts. Here, we will be dividing the distribution into different equal parts. So let's start with the quartiles. The quartiles divide the distribution into four equal parts, while the deciles, right here, divides the distribution into 10 equal parts, while the percentiles divide the distribution into 100 equal parts. So you can see the prefixes that are being used in these words. So you see that there's the word quarter here, which stands for 4. It's like quarters, like in a year. We have the deciles, which has the prefix of D as in decimals. And we have the percentiles, which has a word coming from percent, which is in Latin percentum, which means per 100. So we're going to have a sample data set right here in order for us to help to show in this video how we determine the first quartile, the third quartile, etc. So let us consider this dataset for the exam scores for Stat 101. Similar to how we solve the median, we also need to arrange the data in an array that is either ascending or descending order. So to ease us in that trouble, we already have the array here. And I already named the order or the kth positions. Like this is the first data, datum if you want, a second datum, third datum, etc. So we have 15 samples all in all in this particular example. And the formula that we're gonna make use is this general formula. So this is K. Our K stands for the kth position in the measure. We have the I here, which is the specific quantile number. So quantile, by the way, is also known as the measure of non-central tendency. This is synonymously used with the word fractile in some books. So this is a specific quantile number. So for example, if we're looking for the Q1, the first quartile, the I would be 1. While for P90, the I would be 90. I think that's pretty much straightforward. For M, we are looking for the number of parts. So clearly, for the quartiles, the M would be 4. For the deciles, it would be 10. And for the percentiles, it would be 100. While N, like I mentioned, is either your sample size or your population size. So this formula is not entirely new to us. This is again similar on how we find the median of the distribution. Only that, of course, we divide the distribution into two equal parts. So for the median, in particular, this would be equal to 1 over 2 times n. So we're gonna get the sorry, not yet the median itself, but we're gonna make use of this k for the median. So whatever is the distribution, or the centermost or the middlemost value of the distribution, this would correspond to your median value. Now, what are our rules for our k? So we have two simple rules for k. If k is an integer or specific accounting number, since we're counting an array, so the lowest number that we'll have is 1 anyways. So if k is a counting number, then we need to find the k would be the average of the kth and the k plus 1th positions. So we need to detect the kth position and as well as the k plus 1th position and get the average of those two numbers. Okay, pretty much clear. However, if k is not an integer or not a counting number, then we need to round up the value of k to the next whole number. This is also called as ceiling, the ceiling value of whatever integer. So meaning we need to round up regardless of the value of the decimals of k. So usually our rules for rounding off or rounding up only starts at, if the number to the digit to the right is 5 or more. But in this case, we're gonna get the ceiling value and we're gonna round up whatever or regardless than the decimal is, even if it's 0.01 or 0.002. Okay, so let's have some practice, shall we? So we'll need to find the values of our k here. And for number 1, we need to determine the value of our Q1. For number 2, it's Q2. Number 3, Q3, and so on. So let's start with Q1. So we need to first determine our kth number. So our since it's 1, our numerator will be 1. Our m would be 4 since we're dividing into 4 quartiles rather, and we multiply that by n. Our n here, as we all know, is 15. So we multiply that by 15, and we'll see what will happen then. So we have 1/4 multiplied by 15. You can go ahead and use a calculator if you want. So that's gonna become 15 over 4, which is simply divide. It's gonna give us 3.75. So again, applying our rule number 2, since our k is not a natural number, we need to always round up. So this will lead us to the k value of 4. So meaning we need to find our fourth number. That's gonna be our Q1. Okay, let's go ahead. Here's our fourth number, 63. So therefore, we can go ahead and say that our Q1 is equal to 63. Okay. I think that's pretty much clear. Let's go ahead for Q2. So for Q2, our kth value will be equal to 2 over 4, because again, it's quarter. So that's why the value of 4 here. It's Q2, that's why 2 here. And we're going to multiply it by our sample size 15. Notice 2 over 4 is 1/2. That's going to be 1/2 of 15. So divide, it's going to become 7.5. We're going to round off, so therefore our kth value is the 8th one. Therefore, just need to determine the 8th value. So this is 75, and that's our 8th position. So hence, our Q2 is equal to 75. Going ahead with our Q3, similar procedure. Kth value is equal to 3 over 4, multiply that by 15. Let's do the math. You can use a calculator again to divide it by 4, multiply it by 15. That's going to give us 11.25. Okay, so 11.25 is going to give us a kth value of 12 by rounding off. So we need to determine the 12 value. That's going to be 85, and that's our Q3. Okay, so Q3 equals 85. Before we proceed to the next portion, you need to understand that we need to give some interpretations with our quartiles. So to start off with our Q1, since this is the first quartile and we're dividing the distribution into 4 equal parts, how would we interpret this? We would say that 25% of the distribution, if these are students, you can say 25% of the students, if these are participants, whatever this is. So to make it a general manner, we're going to make use of the term distribution. So 25% of distributions have scores below 63. Okay. For Q2, 50% of the distribution, not distributions, that's not plural. 50% of the distribution have scores below 75, and for this one, 75% of the distribution have scores below 85. We can also use the contrary or the opposite way to describe this. So just an example, you can also do this for Q1. We can also say the complement of 25 is 75%. So 75% of the distribution have scores above 63. So whatever you prefer. The idea is if whatever is your Q value or your non-central position value, the word that you're gonna make use is the word below. So notice there. Okay, So let's proceed to the last 4 items. For D3, so to determine the kth value, it's going to be 3. It's decile, so we're going to divide it by 10, and then we're going to multiply that by 15. So we can go ahead and use our calculators for that. So 3 divided by 10 multiplied by 15 is going to give us 4.5. So this is going to be rounded off to 5. So, okay. Let's go back to our data set. The fifth value is 65. I'm going to note that. So therefore, our D3 is equal to 65. So we can give a an interpretation for that decile 3. So that's going to be 30% of the distribution falls below or have scores falls below 65. Okay, let's proceed. D7, so the kth value first, so that's going to be 7 because of D7 right here. 10 because it's a decile multiplied by 15. So let's go ahead and directly go write that. 7 divided by 10 times 15 is going to give us 10.5. We're going to round that off by rule 2. So our k is going to be 11. And what's the 11th value? Let's see, that's going to be 82. And our D7 therefore is 82. Let's double check. Yep. Okay, so this tells us that 70% of the distribution falls below the score of 82. I'll just put it in context. Last two numbers, P20. So we're gonna have the kth value first. Numerator is 20 because we're looking for the P20. Since it's percentile, it's gonna be divided by 100. Multiply that by 15. That's gonna give us 20 divided by 100. Multiplied by 15. That's gonna give us 3. Okay, so notice that this is the first time we are seeing a whole number. Okay, so we're gonna make use of the rule number 1. If the k is a whole number, we're gonna find the average of the kth and the k plus 1th term. So our k is 3, therefore our k is 3. The third number is 61. Okay, let me note that first. That's 61. While the k plus 1th, which is equal to 4, the fourth number is 63. Okay, let's do that. 63. Now, in order for us to get the P20, we need to get the average of 61 plus 63 divided by 2. I think that's pretty straightforward, but we can go ahead and try to compute that if you want. Divided by 2, that's going to give us 62. And this 62, everybody, is we can interpret this as 20% of the distribution falls below the score of 62. And last, we have for the kth one, it's going to be 85 for the numerator because we're looking for P85 divided by 100 and multiply that by 15. So let's do the math. 85 divided by 100 times 15. The answer is 12.75. Applying rule number 2, our k is 13. Okay, so since it's 13, we're going to look at the data set. The 13th value is 88. Let's go ahead and write that. So P85 is equal to 88, giving an interpretation for that because that's important, meaning 85% of the students or your students falls below the score of falls below 88. Okay, and that's how we compute our fractiles or our quantiles, everybody. I hope you learned something from this video, and yeah, I hope you will use this for your exams. Again, the interpretation can be done conversely if you want to describe the right-hand side of the distribution rather than the left-hand side. So it's really up to you. Okay, so thank you very much. I hope this helps, and see you in the next video. Bye.